Now let's go back and actually consider what the input impedance is going to be. Here's our transmission line connected onto our load, ZL. It has a characteristic impedance of Z0, and it is L meters long. Right here is the load voltage, and this is the load current. Right here is the input voltage. It's also where we measure the input impedance, which we're going to be calculating, and then we're going to connect this onto a generator that has a resistance of Rg and that has a voltage of Vg. So there's our transmission line connected onto the generator on the front end. And if we wanted to know what Zn is, Zn is going to be Vn divided by In. Here's In right there. Now let's look at this front end just from the point of view of a circuit, of our circuits class, like this. Here is Vg, here is Rg, and here is Vn. When would Vn equal Vg? The only time that would happen is if you had an open circuit right here, and then there would be no current in the generator. The input current would be 0, and then the voltage Vn would equal Vg. But that's not a typical case, because we do in fact have this transmission line connected on here with its load on the end, and as a result Vn is not equal to Vg. So Zn is not simply determined by the generator, it's going to be determined by the combination of the generator and the transmission line. So let's go see if we can solve this problem. Here's Vg right there. Here's Rg, Z0, and ZL. We're going to write our standard voltage equation. V of Z is equal to V0 plus e to the minus j beta z plus V0 minus e to the plus j beta z. Remember that V0 minus is the complex reflection coefficient times V0 plus. Well, right here is the location for z equal to 0, and here is the location for z equal minus L, where L is the length of the transmission line in meters. So if I wanted to know VL, that would be the voltage at z equals minus L. Sorry, not VL, Vn. Right here's Vn. So if I want Vn, I look at z equals minus L. Let's substitute that back in. That gives us V0 plus e to the minus j beta, and then when I put in minus L, that minus changes to a plus. And then let's put in gamma V0 plus e to the j beta, and when I put in minus L, there we are. So there's Vn. Similarly, let's write an equation for In. That is going to be I at z equals minus L. That's going to give us I0 plus e to the plus j beta L plus I0 minus e to the plus j beta L, and then this changes to negative. I made a little mistake here on this, made a little mistake right there on that sign. That should be a minus. And remember that I0 plus is V0 plus divided by Z0, and I0 minus is V0 minus divided by Z0. And that gives us that Zn is going to be equal to V0 plus times e to the plus j beta L plus gamma e to the minus j beta L. E to the minus j beta L. And that's going to be divided by V0 plus divided by Z0 times e to the plus j beta L minus gamma e to the minus j beta L.